Hello students, welcome to this lecture on areas related to circles. So in this lecture we will continue exemplars problem on areas related to circles. Okay, so let us start. So in question number 1, here we have to find the radius of a circle whose circumference is equal to the sum of the circumference of two circles of radii 15 centimeter and 18 centimeter. Okay, so find the radius of a circle. So here first of all let the radius of a circle be r. Okay, so therefore the circumference of a circle, this is equal to 2 pi r, and let the radii of two circles are r1 and r2 whose values are 15 centimeter and 18 centimeter respectively. That is, r1 is equal to 15 centimeter and r2 is equal to 18 centimeter. And now by given condition, here circumference of circle, this is actually equal to circumference of first circle plus circumference of second circle. So we know here the circumference of circle is 2 pi r, and we know circumference of first circle is 2 pi r1, and we know circumference of second circle is 2 pi r2. Okay, so it implies 2 pi r, this is equal to 2 pi r1 plus 2 pi r2, and here 2 pi is common in both sides, so here we can cancel out here. So it implies r, this is equal to r1 plus r2, and here we have given the value of r1 is 15 centimeter and r2 is 18 centimeter. So it implies r is equal to 15 plus 18, that is actually equal to 33. Okay, so therefore the radius r, this is equal to 33 centimeter. Hence the required radius of a circle is 33 centimeter. Okay, so now let us move to next problem. So in next problem, here we have given this figure. Okay, so in this figure basically a square is inscribed of a circles. Okay, so inscribed in a circle. So in figure, a square of diagonal 8 centimeter, so its diagonal is 8 centimeter, and this square is inscribed in a circle. So find the area of this shaded region. So we need to find the area of this shaded region. Okay, so let us find. So let the side of a square be a and the radius of circle be r. Okay, and given that length of the diagonal of square is 8 centimeter. Okay, so we have given this, the length of the diagonal of a square is 8 centimeter, and we know the diagonal of this square is side into root 2. Okay, so that is a times root 2, this is equal to 8, and it implies a is equal to 4 times root 2 centimeter. So the side of this square is 4 times root 2 centimeter. Now diagonal of a square, this is actually diameter of a circle. Okay, so it can be observed from the figure. So you can observe from this figure. So actually here the diagonal of a square basically equal to diameter of the circle, and here diameter of square is 8. So radius of circle is r, that is diameter by 2. Okay, and this is equal to 8 by 2, this is equal to 4 centimeter. So it implies r, that is radius of the circle, is 4 centimeter, and therefore area of circle, this is equal to pi r square, and this is equal to 5 times 4 square, that is 16 pi centimeter square. Okay, so area of circle is 16 pi centimeter square, and area of square is side square, that is 4 times root 2 square, and this is equal to 32 centimeter square. Okay, so now, so the area of shaded region, so this shaded region actually area of circle minus area of square. Okay, so area of shaded region is basically area of circle minus area of square, and this is equal to 16 pi minus 32 semi square. Okay, hence the required area of the shaded region is 16 pi minus 32 centimeter square. Okay, so now let us move to next problem. So in next problem, here we have to find the area of a sector of a circle of radius 28 centimeter and center angle 45 degree. Okay, so first of all, you can draw the figure. So this is actually our actual figure. So this is our circle of center O, and here the angle of the sector for at center is 45 degree. Okay, so this is our sector, and we have given the radius of this given circle is 28 centimeter. Okay, so we have given radius is 28 centimeter. So given that radius of a circle R, this is equal to 28 centimeter, and measure of center angle theta, this is equal to 45 degree. So student, now recall the formula of area of a sector of a circle. Okay, so therefore area of a sector of a circle, that is actually equal to pi square divided by 360 degree into angle theta. Okay, so you know this formula, area of a sector of a circle, this is equal to pi square by 360 degree into theta. And now if we put these values, pi 22 by 7, theta 45 degree, okay, pi r square by 360 degree into theta. Okay, so if we put these values, 22 by 7 into 28 square divided by 360 into 45 degree, and this is equal to 22 into 28 into 28 by 7 and into 45 degree by 360 degree. Okay, so this is equal to 22 into 4 into 28 into 1 by 8, and this is equal to actually 308 centimeter square. Okay, so actually a formula for area of a sector of a circle is actually pi r square divided by 360 degree into angle theta. Okay, so hence the required area of a sector of a circle is 308 centimeter square. Okay, so this is the required area of a sector of a circle. So now let us move to next problem. So in next problem, here we have the wheel of a motorcycle is of radius 35 centimeter, and how many revolutions per minute must the wheel make so as to keep a speed 66 km per hour. Okay, so we need to find how many revolutions per minute. So let us solve this problem. So given that radius of wheel R, this is equal to 35 centimeter. Okay, and circumference of wheel is 2 pi r. So 2 pi r. So this is equal to 2 into 22 by 7 into 35. That is equal to 220 centimeter. So but speed of the wheel is 66 km per hour. That is actually 66 into 1000 by 60 meter per minute. Okay, and this is equal to 1100 into 100 centimeter per minute. Okay, and it is equal to 11,000 centimeter per minute. Okay, and therefore the number of revolutions in 1 minute is equal to 11,000 divided by 220, that is 500 revolution. So hence the required number of revolution per minute is 500. Okay, so this is the required number of revolutions per minute. And now let us move to next problem. So in next problem, here we have a cow is tied with a rope of length 14 meter at the corner of a rectangular field of dimensions 20 meter by 16 meter. So find the area of the field in which the cow can graze. Okay, so first of all we draw the figure. So the following situation can be represented by this figure. Okay, so in this figure we let A, B, C, D be a rectangular field of dimension 20 meter by 16 meter, and suppose a cow is tied at a point A, and let length of the rope B AE is equal to 14 meter, that is equal to R. Okay, so here this is actually AE. Okay, and AE is equal to 14 meter, and we know the formula of area of sector. Okay, area of sector AFGA, that is theta by 360 degree into pi r square. Okay, so therefore the area of the field in which the cow grazed, that is actually area of the sector AFEG, that is equal to theta by 360 degree into pi r square. Okay, and here theta is 90 degree. Okay, so here theta is 90 degree and r radius is 14. Okay, 14 meter. Okay, so, and now if we put these values in this formula, then we'll get this is equal to 90 by 360 times pi times 14 square. Okay, so the angle between two adjacent sides of a rectangle is actually 90 degree. And now if we simplify, if we put the value of pi is 22 by 7, then we'll get this is equal to 1 by 4 times 22 by 7 times 196. Again, if we calculate it, then we'll get this is equal to 154 meters square. Okay, so therefore the area of the field in which the cow grazed is 154 meter square. And now let us move to next problem. So in next problem, here we have this figure. Okay, so we have to find the area of the flower bed with semicircular ends that is shown in this figure. Okay, so let us see how to solve this problem. So first of all, here length and breadth of circular bed are 38 centimeter and 10 centimeter respectively. Okay, and we know area of rectangle ACDF, that is actually length into breadth. Okay, so here the length is 38 centimeter and breadth is 10 centimeter. So therefore area of rectangle ACDF, this is equal to 38 times 10, that is equal to 380 centimeter square. Okay, and both ends of the flower bed are semicircles. So therefore radius of semicircle is basically df over 2. Okay, so df over 2, that is 10 by 2, that is equal to 5 centimeter. And therefore area of semicircles, this is equal to pi r square by 2, and this is equal to 5 square by 2, and this is equal to 25 pi by 2 centimeter square. And therefore area of the two semicircles is 2 times area of the one semicircles. Okay, that is 2 times 25 by 2 pi, that is equal to 25 pi centimeter square. So therefore total area of the flower bed, so total area of this flower bed is basically equal to area of ACDF, area of this rectangle ACDF, plus 2 times area of the semicircle, area of two semicircles. Okay, so total area of flower bed, this is equal to area of rectangle ACDF plus area of two semicircles. And here the area of rectangle ACDF, that is equal to 380 centimeters square, and we also find the area of two semicircles, that is 25 by centimeter square. Okay, so therefore total area of flower bed, this is equal to 380 plus 25 pi centimeter square. So now let us move to next problem. So in next problem, here we have this figure. So in this figure, here AB is a diameter of the circle, and AC is given to us 6 centimeter, and BC is given to us 8 centimeter. And here we need to find the area of the shaded region. And here we have to use the value of phi is 3.14. Okay, so let us solve this problem. So we have given that AC is 6 centimeter and BC is 8 centimeter. And we know that triangle in a semicircle with hypotenuse as diameter is right angle triangle. Okay, so therefore angle C, this angle is 90 degree. Okay, so this angle is 90 degree, and in right angle triangle ACB, here we basically use Pythagoras theorem, then we get AB square, this is equal to AC square plus CB square, and it implies AB square, this is equal to 6 square plus 8 square, since AC is given to us 6 centimeter and BC is given to 8 centimeter. Okay, so AB square, this is equal to 36 plus 64, that implies AB square is equal to 100, and therefore AB is 10 centimeter. Okay, so here we take basically AB is positive 10, since the side cannot be negative. Okay, so therefore area of triangle ABC, this is equal to half times BC into AC, that is equal to half into 8 into 6, that is equal to 4 into 6, that is 24 centimeter square. Okay, so here the diameter of the circle AB, this is equal to 10 centimeter, and therefore radius of circle R is 10 by 2, that is 5 centimeter. Okay, and area of circle is pi R square, that is pi 5 square, and here we use the value of pi is 3.14, so this is equal to 3.14 times 5 square, and this is equal to 3.14 times 25, this is equal to 78.5 centimeter square. Okay, so now area of the shaded region. So now area of the shaded region, basically area of the square minus area of the triangle. Okay, so here the area of circle is 78.5 centimeter square, and area of triangle ABC is 24. So therefore area of the shaded region, this is equal to 78.5 minus 24, that is equal to 54.5 centimeter square. Okay, so therefore area of the shaded region is 54.5 centimeter square. And now let us move to next problem. So in next problem, here we have given this figure, so find the area of the shaded field that is shown in this figure. Okay, so we have given this length is 6 meter, this is 8 meter, and this is 4 meter. So let us solve this problem. In a figure, here we join E and D. Okay, here we join ED, and from figure radius of semicircle DFE, R is equal to 6 minus 4, that is 2 meter. Okay, so radius of this semicircle is 2 meter. And now area of rectangle ABCD, area of this rectangle ABCD, this is equal to actually BC times AB, and this is equal to 8 times 4, and this is equal to 32. Okay, 32 meter square. So area of rectangle ABCD, this is equal to 32 meter square, and area of this semicircle DFE, this is equal to pi R square, and here R is 2 meter, so pi times pi R square by 2, that is here the R is 2 meter, so pi times 2 square by 2, that is 2 pi meter square. Okay, so area of this semicircle is 2 pi meter square. Okay, now if we add area of this rectangle ABCD and area of this semicircle DFE, then we'll get the total area of this shaded region. Okay, so therefore this area of the shaded region, this is equal to area of rectangle ABCD plus area of semicircle DFE, and this is equal to 32 plus 2 pi meter square. Okay, and then move to next problem. So in next problem, here we have to find the area of the shaded region in figure. Okay, so first of all, visualize this, observe this figure, and here we have basically given this length is, total length is 12 meter, and here the total length is 26 meter. Okay, and let us solve this problem. So first of all, join GH and EF or FE. Okay, so here first of all we join G and H and F and E, and here the breadth of the rectangle BC, this is equal to 12 meter, and breadth of the inner rectangle, this is actually equal to inner rectangle EFGH, is equal to 12 minus 4 plus 4, that is 4 centimeter, which is equal to the diameter of the semicircle EGF. So D is equal to 4 meter, and therefore the radius of the semicircle R is equal to diameter by 2, that is 2 meter. Okay, so the therefore length of the inner rectangle EFGH, this is equal to 26 minus length of the inner rectangle EFGH is equal to 26 minus 5 plus 5, that is equal to 16 meter. Okay, and therefore area of two semicircles EGF and HIG, this is equal to 2 times pi R square by 2, that is equal to 2 times pi 2 square by 2, that is equal to 4 pi meter square. Okay, so the area of two semicircles EGF and HIG is equal to 4 pi meters square, And now the area of inner rectangle EFGH, this is actually your length into breadth. So here length is EH and breadth is FG, and here length EH is 16 meter and the breadth EFG is 4 meters. So area of inner rectangle is 16 times 4, that is 64 meters square. Okay, and now area of outer rectangle ABCD, this is equal to 26 times 12 and this is equal to 312 meters square. And therefore area of shaded region, this is actually equal to area of outer rectangle minus area of two semicircles. So here area of outer rectangle is 312 meters square and area of two semicircle is 64 plus 4 pi. Okay, so this is equal to 312 minus 64 plus 2 pi 4 pi, that is equal to 248 minus 4 pi meters square. Okay, so therefore the area of shaded region, area of this shaded region is equal to 248 minus 4 pi meters square. And now let us move to the next problem. So in next problem, here we have to find the area of the minor segment of a circle of radius 14 centimeter when the angle of corresponding sector is 60 degree. Okay, so this portion is actually minor segment. Okay, here if we take C here, okay, so ACB actually a minor segment, and here this angle is 60 degree, and we have given the radius of this circle is 14 centimeter. So given that radius of circle R is 14 centimeter and angle of the corresponding sector, that is central angle theta, is equal to 60 degree, and since this triangle AOB here, the OA and OB, they are equal since they are actually same radii of the circle. Okay, so OA is equal to OB, radius of the circle, that is triangle AOB. This is isosceles. So it implies angle OAB, this is equal to angle OBA, and they are actually equal to 60 degree. So now in triangle OAB, so angle AOB plus angle OAB, this plus angle OBA, this is 180 degree. So it implies theta is 60 degree. So that is angle OAB, this is equal to angle OBA, this is equal to 60 degree, and actually this is also equal to angle angle AOB. So since all angles of triangle AOB are equal to 60 degree, that is triangle AOB is an equilateral triangle. Okay, so this triangle is an equilateral triangle. So also OA, this is equal to OB, this is equal to AB, and they are all equal to 14 centimeter. So area of triangle OAB, this is equal to root 3 by 4 times side square, and here the side is 14 centimeter. So this is equal to root 3 by 4 times 14 square. Okay, so this is equal to root 3 by 4 times 196, and this is equal to 49 times root 3 semi square. Okay, so therefore the area of the triangle OAB, this is equal to 49 times root 3 semi square. And now area of the sector OBAO, that is equal to pi r square by 360 degree into theta. Okay, and this is equal to 22 by 7 into 14 into 14 by 360 into 60 degree, and this is equal to 22 into 2 into 14 by 6, that is equal to 22 into 14 by 3, and this is equal to 308 by 3 semi square. So therefore area of minor segment, this is equal to area of the sector OBAO minus area of triangle OAB, that is equal to 308 by 3 minus 49 times root 3 semi square. So hence the required area of the minor segment is 308 by 3 minus 49 times root 3 semi square. Okay, and now let us move to next problem. So here we have to find the area of the shaded region in figure, where arcs drawn with centers A, B and D intersect in pairs of midpoint P, Q, R and S of the sides AB, BC, CD and DA respectively of a square ABCD. So here we have to use the value of pi is 3.14. Okay, so now let us solve this problem. So first of all, we have given side of square BC is 12 centimeter, and since Q is a midpoint of BC, so therefore radius BQ, this is equal to 12 by 2, that is equal to 6 centimeter. Okay, so now area of the quadrant BPQ, this is equal to 5 r square by 4, that is 3.14 times 6 square by 4, that is equal to 113.04 by 4 centimeter square. So area of the 4 quadrants, this is equal to 4 times area of one quadrant, BPQ, that is equal to 4 times 113.04 by 4, that is equal to 1123.04 centimeter square. Okay, so now therefore area of the shaded region, so now area of this shaded region is equal to area of the square minus area of the 4 quadrants, that is equal to 11144 minus 113.04, that is equal to 30.96 centimeter square. Okay, so therefore the area of this shaded region is equal to 30.96 centimeter square. And now let us move to the next problem. So in this problem, we have given this figure. So in this figure, arcs are drawn by taking vertices A, B, and C of an equilateral triangle of side 10 centimeter. To intersect the sides BC, CA, and AB at their respective midpoints D, E, and F. Okay, and find the area of the shaded region. So here, since ABC is an equilateral triangle, then angle A, angle B, angle C, they all are equal to 60 degree, and AB is equal to BC is equal to AC. This is equal to 10 centimeter. So EF and D, they are midpoint of the sides. So therefore AE equal to EC is equal to CD is equal to BD is equal to BF is equal to FA. They are all equal to 5 centimeter. So now area of the sector CD is equal to pi r square by 360 degree into theta, that is 60 into 3.14 into 5 square by 360, and if we calculate it, then we get this is equal to 13.0833 centimeter square. Okay, so therefore the area of the shaded region, this is actually equal to 3 times area of the sector CDE, that is equal to 3 times 13.0833. This is equal to 39.25 centimeter square. Okay, so I stop here this lecture. Thank you very much to all of you.